Good morning. In today's class, we will discuss about the defined scheme of classification of climate. Now, as we know that climate is the average weather condition, and we all know that within climate, it has different elements or it has different components like pressure, temperature, wind speed, rainfall, snowfall, etc. etc. Now, each of these elements, if we combine them, uh, they are vary from place to place. So, thereby, art has an infinite variety of different combination of those elements, and thereby it has variety of climatic conditions at different places. So every place of art is slightly different in some aspect from the other. The infinite variations in climate from place to place is determined by the different combinations of various atmospheric processes and various atmospheric conditions. Now, in a simple way, if we try to uh, show the climatic conditions of any area, then we will represent the climate by some graph, and this graphical representation of the basic climatic parameters, that is mainly the temperature, precipitation, etc. That is known as the graphical representation is known as climograph. So, what are the components of the climograph? In a climograph, generally we show three components. In the horizontal x-axis, it is the time scale. Generally, it is shown in terms of months. So we take the records of different climatic components for each month. In the y-axis, in one part or one side of the y-axis, we show the precipitation, that is the rainfall or snowfall of any area, and in the other side of the vertical y-axis, we show the temperature in centigrade or Fahrenheit scale. So these are the three main components what is found in a more simple climograph, and generally all these climatic elements like the precipitation and temperature, they are shown in this graph in terms of average monthly values, that is in terms of average monthly temperature or in terms of average monthly precipitation. Now, if we try to classify the climate pattern of the world, that is on the basis of certain um, components, certain parameters, if we try to group the different places of earth in some common group, the major problem what we found is that the climatic condition is not fixed, and there are many elements. Now, if we classify climate on the basis of a single element. Say for example, we are classifying climate on the basis of temperature. Then it will be very much simplistic, simple, and it will not tell the other components, the other elements of the climate. So basically, it will hardly help to depict the climatic condition of any region. Now, if we add more than one component, that is more elements are used, then it will be more cumbersome, it will be more complex. So here lies the difficulty. By taking one component, it will be more simple, it will not telling the entire climatic condition, whereas if we take multiple components, it will become more complex. And not only that, all these components or these climatic elements are not fixed, they are varied place to place, time to time. Now, when we approach to classify climate, there are two ways by which classification can be done. The first approach is known as empirical approach. In this type, the climatic condition is denoted through some observed phenomena or observed effects in an area or in a region. Say, for example, we are defining the climatic conditions simply on the basis of precipitation. We are defining climatic conditions simply on the basis of temperature, simply on the basis of soil. So, depending on the observed effect of any element in an area, we divide or we classify climate, and that approach of classification of climate is known as empirical classification. The second type of approach of climatic classification is known as genetic approach. In this type, basically we are trying to study the causes behind the climatic types. So basically we are trying to find the reasons behind the occurrence of any particular type of climatic condition or any particular type of climatic elements. So we are trying to find the genesis of that particular condition. So that is why these kinds of approach of classifying climate is known as genetic classification. Now, the first classification of climate was proposed by a German botanist and climatologist during his research years, um, in the early part of 20th century, that is in the 1900 years. His known his name is Vladimir Köppen. Now, after the proposal of fast classification, basically in uh, the year 1900, uh, Köppen proposed a climatic classification on the basis of world vegetation map. So he observed the vegetation types over the worlds, and depending on these vegetation types, he classify the climatic conditions of the earth into five groups, that is megatherms, xerophytes, mesotherms, microtherms, and echistotherms. So these are the five groups or five different type of climatic conditions suggested by Köppen depending on the different types of vegetation. Now, after this proposal of climatic condition in the 1900 year, Köppen revised his classification first in the year 1918. At this time, Köppen made attention to the monthly average temperature and monthly average precipitation. And also, depending on monthly values, he also try to uh, observe the annual values of temperature of any region and the annual values of precipitation of that region also. Depending on these precipitation and temperature values, Köppen proposed a map in the year 1931. Now, after this, there are further modifications done in the year 1953, in the year 1936. So after all these modifications, nowadays came to know about the modified and updated version of Köppen climate classification, and till date it is the most widely accepted climatic classifications among the scientists of the world. Now, the classification of Vladimir Köppen is basic, as you can see that he is basically observing certain observed effects, certain phenomena like the rainfall, like the vegetation cover, like the temperature condition, and he did not try to find the reasons behind this. The Köppen climate classification system uses mainly the mean monthly and annual values of temperature and precipitation, and depending on these values, Köppen developed a classification system having five principal groups. The groups are humid tropical climate, dry climate, humid mid-latitude climate, polar climate, and the last one, although it is not initially proposed by Köppen, but later it was introduced by several other climatologists or several other meteorologists, that is the highland climates or high altitude climates. Now, all of these different groups of climates are mainly based on the uh, basis of precipitation, except the dry climate, which is defined on the basis of temperature. Now, if we look at the Köppen system of classification, the rules, the particulars of Köppen system, then Köppen tried to define the climate system, and he tried to uh, show the climate different climate groups in terms of some symbols, in terms of some alphabetical letters. He used combination of some letters in which the first letter that designates the major type of climates. Like I previously told you, the humid tropical climate, dry climate, humid microthermal climate, humid mesothermal climate, polar climate. So all these climatic types, they are the major groups, and thereby they are symbolized by these uppercase alphabetical letters. The second letter in Köppen system, if it is associated with the major group like A, C, and D climate, then the second letter denotes the seasonality of precipitation, and it is generally represented by some small letters, where F, small f, indicates precipitation found throughout all the time of the year, small w indicates dry winter, and small s indicates dry summer. But in case of B climate, there we use, or Köppen used, two capital letters, that is S and W, which is indicating the uh, aridity of the climatic condition. In case of E-type climate, the two capital letters, that is T and F, are used. The third letter of the Köppen system designates different temperature regimes and sometimes other parameters like the fog frequency, etc. Now, if in the third letter, if it occurs with B, then it indicates whether there is hot or cold condition. Then it is symbolized with small alphabets like K and H. For hot condition it is small h, for cold condition it is K. So these are the letters, these are the alphabets used to symbolize the different climatic conditions according to Köppen classification system. Now, as I already told you, the climatic system or climatic classification proposed by Köppen in 1918, and according to it, Köppen divide five major types, that is the tropical moist or humid climates, which is designated as the capital A, dry climate, which is designated as capital B, moist mid-latitude climate with mild winters as capital C, moist mid-latitude climates with severe winters, capital D, and polar climates as capital D. So these are the five groups initially proposed by Köppen. Later, this highland climate, that is designated as capital H, is also introduced or also incorporated within this climate classification system. Now, for A type, that is the humid tropical climate, the average monthly temperature always exceeds 18 degrees centigrade, and there is almost no winter season. So no cold condition, winter condition is um, found to occur really, because the temperature condition, average temperature, is always higher than 18 degrees centigrade. So no real winter. The annual rainfall is very high. Uh, it always exceeds the value of annual evaporation. So there is always a net water surplus. Now, this tropical humid climate where there is a lot of water both in the atmosphere and as well as in the ground. And there we found mainly the vegetation is mainly the tropical rainforest, as there is sufficient amount of rainfall is there. And the this climate is again subdivided into three groups, and in this case the small alphabets are used: F, M and W, which indicates the tropical rainforest, tropical monsoon climate and tropical savanna climate. The second major group according to Köppen classification system, that is the dry climate, which is indicated by capital B alphabet. The vegetation in this type is mainly of xerophyte type. On an average, in this condition, the potential evaporation always exceeds precipitation throughout the year. So there is a scarcity of water found in this climatic condition. Now, the dry climatic condition divided into two groups, and in this case, as it is associated with the B, so instead of small letters here, capital S and capital W are used, as I told ID earlier, and the combination of these two letters indicates a arid to semi-arid condition. The steppe type of climate or vegetation cover is found, whereas when it is W, that is the combination of these two letters, indicates a extremely arid condition, that is the desertic condition is the climate type. Now both these uh, BS and BW type of climates are again subdivided into two groups. The first is BSH, where it indicates a semi-arid, hot, low latitude steppe climate, and the second is BSK, semi-arid, cold, mid-latitude steppe climate. So you can see the H and K are basically indicating a hot and cold climatic condition, and depending on that, the latitude condition also varies. In case of BW, when H and K are added, it indicates arid, low latitude desert climate, and the second group, that is arid mid latitude desert climate. The third group indicates the temperate climate, or it is also known as humid mesothermal climate. In this climatic condition, the mean temperature of the coldest month lies between about 18 degrees centigrade to minus 3 degrees centigrade. So the seasonal differences are extremely found to occur and extremely observed in these climatic conditions. Plants in these climatic types adapted to moderate heat and moisture condition. Now this temperate climate can be again subdivided into three groups. The first type, that is CF, where they are found year-round precipitation, year-round rainfall. The second type, CS, that is summer dry condition, so there is no rainfall during summer. And the third type, that is CW, where there is no precipitation during winter. Now both these CF and CS can be again divided into two groups. The CFA, that is humid subtropical climate, where the warmest month temperature exceeding 22 degrees centigrade. The second type, that is the marine west coast warm climate, where the warmest month temperature is less than 22 degrees centigrade. The CS type, it has also two different types: CSA, that is mild with hot dry summer, and CSB, that is summer dry and warm summer. Next is the humid microthermal climate, or it is often known as cold forest climate. The mean temperature of this climatic condition, the temperature of the coldest month is below minus 3 degrees centigrade, but the temperature of the warmest month is above 10 degrees centigrade. The plantation or the vegetation found here is evergreen deciduous forest and steppes mainly. This climatic condition can be again subdivided into three groups: DF, DW, and DS, that is the humid continental precipitation throughout the year, humid continental winter dry, and humid continental summer dry. DF and DW types are again subdivided into three parts: summer long and warm continental, summer long and cool, summer short and cool types. Whereas DW type is subdivided into four groups: humid with severe dry winter hot summer, humid with severe dry winter warm summer, dry winter cool short summer, and lastly the very cold and dry winter cool summer. The fifth type, that is the polar climate. Here the vegetation is mainly of hecistothermal type, generally moss, lichens. These type of plants are generally found. The mean temperature of the warmest month in this climatic condition is below 10 degrees centigrade. So even the summer times of these climatic areas are also found to be cool. The polar climates are again divided into two groups, and as I told earlier, here instead of small letters, capital letters T and F are used. ET indicates mild tundra climate with average temperature between 0 degrees centigrade to 10 degrees centigrade. So both in summer and winter temperature lies always below 10 degrees centigrade, whereas EF type, here it is permanently snow covered areas and the temperature almost year around found to occur below 0 degrees centigrade. So always it occurs below the freezing point. So mainly the snow covered areas are fall within this group. The last type is known as the highland climates, which receives generally the high insolation and low temperature condition, low pressure, high precipitation, and larger diurnal range of different climatic components are found to occur in these areas. This high-end climate is basically unclassified because there is great variability according to different altitude, different exposure to sunlight, and different exposure to wind activity. So it would be far too complex to further subdivide these highland climatic conditions, because from our previous classes we already came to know that a single mountain range or a single hillock that does not have all the climatic conditions similar in all the sites, all the altitudes, so thereby the uh, climatic elements vary in different sites in different altitude of those highland areas. So that is why highland climates are not further subdivided, and all the highland areas, all the climatic conditions of the highland areas are grouped under the heading as highland climate. So this is the world map of different climatic types according to the Köppen system of climatic classification. Now, Köppen system of climatic classification, although it is widely used and more or less easy, it has some uh, positive sides, that is merits, and some uh, criticism or demerits also. Firstly, if we look at the merits of Köppen scheme, the scheme only use the alphabets to represent it. So thereby, instead of using a large complex sentence or a large name, using the alphabets, it becomes easy to represent it, along with the main divisions, which are the main 6 types of divisions of climate system. It also identifies other smaller climatic divisions. The major groups boundaries correspond roughly to the general features of the atmospheric circulation systems. The parameters which Köppen used in this climatic system, that is the average temperature, monthly average temperature, and the monthly average precipitation, as well as the annual temperature and annual average precipitation, that are more or less easy to measure. Apart from this, the Köppen climate system is very easy to modify. So new classes of climate uh, systems, climatic divisions can be easily added within this classificatory scheme. Now, although it has many merits, but it has also some limitations. The first and foremost limitation of Köppen scheme of climatic classification is Köppen scheme ignores the causative factors. That is, it is mainly based on the empirical approach of climatic classification. It does not try to find the reason behind those climatic conditions. Secondly, vegetation is not only depends on climate, because as I told you that Köppen is basically divide the climatic system into different groups, mainly based on the observation of different vegetation types. Now, this vegetation is not only depending on the temperature, on the wind, on the precipitation, on these factors, but sometimes apart from these climatic conditions, some local issues like the soil cover, the nature of the soil, the fertility of the soil, the biological activity, that also have some significant role on the vegetation type. So although two areas of two same latitude areas may have same climatic condition, but because of their soil cover, different soil cover, or because of the different biological activity in those areas, maybe those two areas having same latitudinal condition may have different climatic condition. So Köppen does not take into account those factors. In Köppen climatic system, there are sharp boundaries between the climatic groups due to the use of the vegetation types, which mainly represent the monthly temperature and precipitation. But as we know that temperature and rainfall of any place differ from year to year. It is not fixed throughout all the years. So therefore, the positions of these climatic boundaries will also change accordingly in year to different year, as the climatic condition of any area is not fixed from one year to another year. So thereby, the climatic boundaries may also shift their position from one year to another year. So keeping in mind on these uh, positive sides and limitations of Köppen classification system, another meteorologist, that is another American meteorologist and climatologist, C.W. Thornthwaite, he introduced another classification scheme of climate in the year 1931. and he mainly applied his classification scheme to North America. The classification scheme of Thornthwaite is almost very much similar to Köppen, that it also attempts to define the boundaries of the different climatic groups quantitatively. Um, Mainly, the Thornthwaite classification system is also following the vegetation types, and it also employs combination of symbols to designate the different climatic types. So on this uh, points, Thornthwaite classification scheme is very much closely resemble the classification scheme of Köppen. However, there is also marked difference from the Köppen system of classification. So Thornthwaite basically produced a system in which he take two factors into consideration. One is the precipitation effectiveness, another is the temperature effectiveness. So basically Thornthwaite produced a index that could be determined empirically, and this index of Thornthwaite is known as precipitation evaporation index. Now the index, that is the precipitation evaporation index, was utilized by Thornthwaite to produce different humidity provinces, and these humidity provinces are the first order divisions of Thornthwaite classification scheme. Now, as I told you that Thornthwaite mainly focuses on two factors, that is the precipitation effectiveness and the temperature effectiveness. So the effectiveness of precipitation is basically a function of precipitation and evaporation, and this precipitation effectiveness is calculated by dividing the monthly precipitation by the monthly evaporation. So we get a P by E ratio for each month. Now, by summing the P by E ratio for 12 months, we get the annual P by E ratio, that is known as P by E index. Now, depending on this P by E index, that is the uh, different precipitation effectiveness index, depending on this value, Thornthwaite first proposed the world climate into 5 different provinces. That is the wet humid province, B is the humid province, capital C is the subhumid province, then the semi-arid province demarcated as capital D, and lastly the arid province demarcated as capital E. And the similarity, as I told you, of this Thornthwaite classification system with the Köppen system, you can see that depending on the different humidity province, the vegetation type also changes. So Thornthwaite also have a close look on the different vegetation types in these humidity provinces. That is the rainforest, forest, grasslands, steppe, and the deserts. So all these humidity provinces are separated or distinguished depending on different precipitation effectiveness index values. Now these five humidity zones are again further subdivided into sub sub humidity zones on the basis of seasonal distribution of precipitation, and in this case along with the capital letters which is denoted the different humidity provinces, here we use some small alphabets, that is R, S, W, and D. So R indicates adequate rainfall in all seasons, S is rainfall deficit in summer, W is equal to rainfall deficit in winter, and D is rainfall deficit in all seasons. So all the five humidity provinces can be again subdivided depending on this seasonal distribution of precipitation into this five uh, into these four types, four subdivisions. Now another factor which was considered by Thornthwaite, that is the temperature efficiency. Now temperature efficiency or thermal efficiency is a function of monthly temperature, and this thermal efficiency relates the variation of temperature to the growth of the plants. So depending on these temperature efficiency values, which is also taken as an annual value and indicated as T by E index, it has different values, different numerical values, and depending on we get or Thornthwaite found six different temperature province, and they are indicated as capital A with a dashed sign. So A dashed is indicating by tropical temperature province, B dashed is equal to mesothermal temperature province, C dashed is equal to microthermal temperature province, D dashed is equal to taiga type temperature province, E dash is equal to tundra type temperature province, and F dash is frost type temperature province. And you can see that T by E index gradually decreasing from tropical to frost region. That is the temperature, monthly or annual temperature value gradually decreasing from tropical to the frost climatic conditions. Now the combination of these PE index and PE index, if we plot them in a bound that along the y-axis, Hornet plot the PE index values, temperature effectiveness values, and accordingly he found the six different temperature provinces, that is the tropical, mesothermal, microthermal, taiga, tundra, and frost. And in the y-axis, sorry, in the x-axis, Thornthwaite plot the precipitation effectiveness index, and accordingly he found five different humidity provinces, that is the rainforest, forest, grassland, steppe, and desert condition. Now after plotting the TE index and P index values in this binary diagram, it was found that the regions like A dash, D dash, E dash, and F dash, these are solely controlled. These two regions, these two temperature province, they can precipitation efficiency, and these two temperature provinces thereby again subdivided into five different humidity provinces. So these two temperature province are mainly guided along with the temperature factor by the precipitation factor also, that is the precipitation efficiency. The A dash, D dash, E dash and F dash, these are simply thermal efficient regions, whereas the B dash and C dash are the precipitation efficient regions. Now, combination of different symbols which represents the different PE index and different TE index values, and also the seasonal variation of precipitation gives us the 32 different varieties of climatic types according to Thornthwaite classification scheme. So all these combinations of different alphabets A dash and R, different temperature um, efficiency values, different precipitation efficiency values, and the seasonal values. They give us 32 varieties of climatic types. And you can see that these um, arid conditions, that is the tundra and frost conditions, they are not subdivided into further subdivisions, whereas the other types, there are fewer subdivisions, and depending on the addition of these subdivisions, you will find that there exist different, or there exist about 32 climatic types in the nature. Now, Thornthwaite proposed this classification scheme in the year 1931. Later, Thornthwaite himself modified his climatic scheme by using the concept of potential evapotranspiration. In the earlier scheme, that is in the 1931 scheme, Thornthwaite concerned only with the loss of moisture through evaporation, whereas the moisture can be also lost by plants, and that process is known as transpiration. So in this 1948 scheme, Thornthwaite considered both the uh, loss by evaporation and transpiration. So together, Thornthwaite termed it as evapotranspiration. So by taking into consideration both way, that is both by evaporation and transpiration, in the 1948 scheme, Thornthwaite uh, used the previously devised three indices, that is the precipitation effectiveness, thermal efficiency, and the seasonal variation of precipitation, in a new way, in a new developed way. And in the 1948 scheme, Thornthwaite developed four indices to determine the different boundaries of different climatic types. In this scheme, Thornthwaite used moisture index, the potential evapotranspiration, which is also a function of the thermal efficiency, that is the temperature, the aridity or humidity indices, and lastly the index of concentration of thermal efficiency. Now all these things have a complicated formula by which they can be uh, found, the numerical values are found. uh, I'm not going into that detail by of deducing these mathematical or numerical formulas, numerical values. So Thornthwaite, depending on the moisture index and the thermal province and all other uh, indices, he proposed the climatic types mainly on the basis of moisture index into several groups and symbolized them by some uh, alphabets depending on uh, moisture index which have different values. He proposed different humidity province such as the perhumid, which is symbolized by capital A, the humid conditions, which is symbolized by capital B, the subhumid conditions, which is symbolized by capital C, semi-arid, capital D, and arid, capital E. Now, among these humidity provinces, the A and B and C2, these having the moist climate, whereas the C1, D and E, these three have the dry climatic conditions. Depending on the moisture index values, these humidity provinces are distinguished. Now, the moisture values, if we consider it in terms of centimeter, that is the moisture present in atmosphere or in other forms, uh, if we consider them in terms of centimeter, then depending on the values, and as we know that this moisture present in the atmosphere or in other forms is depending largely on temperature, depending largely on the thermal values. So the values of moisture, depending on these values, it can be divided into different thermal provinces, and the thermal provinces are megathermal, mesothermal, microthermal, tundra, and frost. And these are their corresponding moisture values in centimeter. Now, the moist climate and the dry climatic conditions, they can be further subdivided based on seasonality and precipitation. So the moist climate mainly are the all the B type climates, that is B1 to B4, and the C2 climates. They can be further subdivided depending on this aridity index. So different aridity index values, they can be further subdivided into different groups which have little or no water deficiency, symbolized by capital R, moderate summer water deficiency, capital S1, moderate winter water deficiency, W1, large summer water deficiency, S2, and large winter water deficiency, W2. Similarly, the dry climatic conditions, which are the C1, D, and E types, they can be again subdivided depending on the humidity index, depending on the water vapor available in the atmosphere, and depending on the different values they can be subdivided into again 5 types, which is symbolized with some alphabets, which have little or no water surplus, moderate winter water surplus, moderate summer water surplus, large winter water surplus, and large summer water surplus, and all have different symbols. Now this is the world map of Thornthwaite moisture index values proposed in the year 1948, and although it is mainly applied to um, America, but uh, later, according to Thornthwaite 1948 scheme, it is plotted in all over the world, and this type of climatic condition are found to occur throughout the global land areas according to Thornthwaite 1948 moisture index types. Now, Thornthwaite classification system also have some merits and limitations. If we look at the merits, according in Thornthwaite classification scheme, it has more divisions of climatic types. So the variations of different climatic conditions are better observed in a global scale. Thornthwaite stream also become popular among zoologists and botanists as well as in among geographers. Now, if you look at the limitations or criticisms of Thornthwaite classification scheme, Thornthwaite scheme yielded a major climatic types of 32 different varieties. So often people find it hard to remember all these 32 types. The scheme did not include the causative factors. So again, Thornthwaite classification scheme is a result of an empirical approach. It is not a genetic approach classification scheme. The complex empirical formula devised by Thornthwaite to deduce the precipitation effectiveness value, temperature effectiveness value, potential evapotranspiration value, moisture index values. These have a complex mathematical calculation, and a lot of calculation are used on the basis of these values to determine the climatic type of any particular place. So often the scheme uh, did not get that popularity to common people. Although the geographers, botanists, and zoologists they used this scheme uh, very well, but among common people, uh, among climatologists, this scheme becomes very much uh, cumbersome because it involves a lot of calculation, so it does not get much popularity. After Thornthwaite, another um, climatologist known as Trevartha, he proposed a classification scheme in his book An Introduction to Climate. Uh, Basically, Trevartha produced a classification scheme which is a modified version of Köppen's climate classification scheme. In Trevartha's opinion, the classification of climate given by Köppen and Thornthwaite were very much cumbersome and complex. So Trevartha tried to propose a more simple form of climatic classification scheme. Now, in the classification scheme proposed by Trevartha, he recognized only a limited number of major climatic uh, types, right? Mainly six different climatic groups depending on these temperature and precipitation factors. The main climatic groups identified by Trevartha is the tropical climate, which is symbolized as capital A, dry climate symbolized as capital B, subtropical capital C, temperate capital D, boreal capital E, polar capital A, and the highland climates indicated as capital H. Now, in these different types of climatic groups proposed by Trevartha, except the dry condition, all are distinguished on the basis of temperature factor. But only the dry climate here, precipitation taken into consideration, or precipitation is the primary factor by which this climatic group is distinguished from other types. Now, according to Trevartha, all these different climatic groups can be again further subdivided into different groups or subgroups. The A type climate, that is the tropical climate, is divided into uh, two subdivisions, that is AR and AW, whereas the dry climate, that is the dry um, regions where precipitation is very low, they can be subdivided into BS, that is steppe type climate, and BW, that is desert type climatic condition. The subtropical or C type climate, it can be again subdivided into two types, CS and CF. The D temperate climate can be divided into uh, two DO and DC. These two groups are indicating the oceanic and continental areas. The boreal climate is not at all subdivided. The polar climate is again subdivided into two groups, one indicating the tundra climate and one indicating the ice cap climate. So, depending on all the variations of temperature and classification, um, Trevartha make it a very simple, and he altogether uh, depicts, or he altogether proposed 15, only 15 different types of climatic types found to occur in the entire world. Now, if we look at the merits and demerits of Trevartha's classification, uh, Trevartha's classification mainly emphasizing two principal climatic elements, that is temperature and precipitation. So it becomes very simple to observe or to get the results of these two factors. In this classification scheme, the effects of land and water surfaces on climate have also taken into consideration. Mathematical calculation in this classification scheme is very less or almost negligible. So uh, people found it very easy to classify the different climatic systems of the world. Trevartha also opposed to produce large number of climatic types on the basis of statistical and quantitative parameters. So that is why he recognized only 15 number of major climatic types. Now, although Trevartha's classification is very simple, it has also some demerits or also some limitations. The boundaries of the climatic regions in this classification scheme are based on the average of the climatic conditions over a 30-year period time. So it requires a vast data having a vast time span. Now, for every place, often the availability of data for this long time is almost becomes impossible. So all the data over the years of any region, people does not find it. People are not get those data. Secondly, Trevartha scheme is basically a compromise between the empirical and genetic approach. So it is neither purely an empirical method of climatic classification, not purely a genetic method, a climatic classification, but instead it becomes a mixture or becomes a compromise between these two types of climatic classification. So these are the three main climate classification schemes till date proposed. Different peoples followed different types of climatic classification scheme, but till date the most accepted and most widely used classification scheme of climate is the Köppen classification scheme. So if we look at the climates of India, according India has all the six different major climatic types. That is the tundra climate, glacier climate, humid tropical climate, rainforest, the semi-arid climate. and humid subtropical conditions. So you can see all the different color indicates different symbols, and all the different varieties are found to occur in India in different areas depending on its geographic occurrence. So that's all. That's a brief idea about the classification scheme of climate. Thank you.